Okay, so we'll start with this one. So I said under question 6, right? So I'm going to just fold this right at 6. And so a police helicopter is flying 400 meters above a highway, spots a collision at an angle of depression of 62. And at the same time, the helicopter spots an ambulance at an angle of depression of 27 degrees. Assume the helicopter is between the collision and the ambulance. So regardless of how you want to see it, you got to imagine like this is your highway. This is the ambulance perhaps, and this is the collision. And the helicopter is somewhere up here looking down at both of them. But we're told that the helicopter is between, right? So it's not all on one side. And here's where you have to be, I'm not going to make a big deal, but 62 degrees for the collision. The helicopter is closer to the collision than it is to the ambulance. So that makes sense because you're looking down at a steeper angle. So if this is your horizontal, that's where you measure from. It's 62 degrees down here, 62. Okay. Whereas if you're looking at the ambulance, this is your horizontal, your angle is not as sharp. It's 27 degrees. So that's what I would expect the 27 and 62 to be there. If you got that right, we'll give you 1 mark today for the angles being in the correct place. So that means that if you made the helicopter, if you made it, be a right triangle, that is a -1, okay? And then where 400 meters, that is straight down like this. So the 400 is represented by that dashed line. I give you a mark for that today. So if you have the 400 vertically to the ground, like perpendicular to the ground, you get a mark. And if you have the angles in the correct place like this, you get another mark for that. So 2 marks for that. This is question 6 instead of question 6, right? So 2 marks for question 6 so far, and then I'll start solving the rest. Okay, here we go. If you want to write down, this is from page 41 on question 6. See page 41 in my notes if you want to have a reference to that. We're going to solve that together later. So triangle ABC, right? So we've got ABC. Side A is 27, B is 29, and this is 50 degrees. Okay, what's the measure of angle A? So we want this one. So because this is, we have a pair, it's sine law. So sine of 50 over 29 is equal to sine of A over 27. This is your initial setup. You will get a mark for the setup if it's correct. And then it would be sine of A would be 27 times sine of 50 divided by 29. You get 0.713 and something. Angle A is sine inverse of that. You get another mark for the work and the inverse, right? For this step, I give you another mark. And so angle A ends up being 45.50 degrees. So I guess the closest would be 45 here. Okay. That's the closest we have. So we get, I'll give you 2 marks for all the work and stuff, and of course I would expect you to have the right answer there. So we'll go, instead of 1 point, we'll go 2 marks for that. Then given triangle DEF, so you just make a sketch, DEF like this. D is 62 degrees, E is 58, and side F, which is right here, is 7.5. Calculate the length of side E. We want this one. Can't use cosine law. You need at least two sides. We don't have three sides, so cosine law is out. This is sine law again. First thing you need to do is find angle F. Angle F is 60 degrees. So if you do that work, you get a mark. Once you've got the 60 here, you've got a pair. So it's sine of 60 over 7.5. And then it's sine of what? Of, if I have one side E, I must pick 58. Okay. So if you didn't have 58 here, you would lose a full mark for that because you're not solving for E if that's the case. So obviously there's some work that is needed there. So I will give you a mark for setup and a mark for work and correct final answer. E is 7.34 centimeters. Okay, so this whole thing is another mark. So 7.34, there it is. That's your final answer. Next, X, Y, Z. Y is 2.75. Z is 6.38. X is right here, is 79 degrees. So sorry, let's go back to 2. It's also worth 2 marks. Okay. Question 2 is 2 as well. Next, you have your setup. The sine law again. Sine of Z. No, wait a minute. X, Y, Z. Do you have this set up exactly like mine? Okay, then it's just half a mark for rounding. Yeah. Did I make a mistake here? X, Y, Z. Side Z. Oh, yeah. Apparently, I don't know how to label a triangle properly. Let's try this again. Z is here. This is 2.75. Y is, sorry, 6.38. I got this, guys. I got this. I know math. Okay. Got this. Z is 6.38. Y is over here. This is 2.75. So didn't I have that right after all? Angle X, yeah, 79. Thank you. Is it Isaiah? Yeah. That's what I got wrong here. 79. There you go. So it's not sine law. It is good old cosine law, right? So if I want to solve for this side here, this is side angle side. So cosine law, here we go. X squared is equal to 6.38 squared plus 2.75 squared minus 2 times the first one times the second one. If you remember the pattern, this works quite well. So root of 41.571 and something, and so that's 6.45 centimeters. So here are the marks. I'll give you 1 mark for the correct setup, and then 1 mark for the correct work and final answer. And there it is, 6.45. So this question is worth 2 as well. So 2, 4, 6 for this page so far. Let's keep going. Triangle, fun. You have a weird sense of having fun, Mr. Griggs. Anyways, fun. And so F is 0.4, U is 0.5, N is 0.8. So it's not drawn to scale, obviously. That's okay. What's the value of the largest angle? And so N is the largest angle here. So I have to start with cos of N, because this is side, side, side. The only option is to do this. You're going to add 2 sides and subtract, right? The one that you have to have back here is 0.8. Okay, 0.8 squared. and then it's 0.5 squared plus 0.4 squared, and then it's 2 times 0.5 times 0.4. If you have this, you get a mark, okay, for that step. Cosine of n, the top gives you, oh, it got hole punched. Is it something 23? Is it 0.23? Yeah? What is it? Negative. Negative 0.23? Thank you. It got hole punched on my key here. And bottom is 0.4, okay, which gives you negative 0.575, I believe. So I would give you a mark for having the negative because it's very important to us. So you get a mark for that. And then angle n is going to be cosine inverse of negative 0.575, which means we're going to get an obtuse angle. And it's 125.1 degrees. So 3 marks for this one. So get rid of the 1 point up here and just say it's out of 3 for now. Okay, pilot of a commercial plane spots an airport and an angle of depression of 23. She continues to fly for 3.45 kilometers until the angle of depression is 55. Calculate the distance between the plane's current position, and the airport. So here you go. You ready? You're here. The plane, the pilot, right, sees the airport at an angle of depression. This is the airport. Maybe let's call this pilot 1. And there's a 23-degree angle there, right? But then you continue to fly, right? You have a second location, and from there, it is 55 degrees now, looking down. And so we know that this distance here is 3.45 kilometers. And now you have your diagram. Okay, so I will put a lot of weight on this diagram. I'll say this is two marks to your diagram. So if it's exactly like I have here, 2 marks. If it doesn't look at all like what I have here, if your angle of depressions are not with respect to the horizontal, well, I would go anywhere between 0 and 2. So you decide what you want to give yourself here. You be the teacher today. Okay. So how are we going to solve this? This is what I'm going to do. I don't know if you see the 180 here. So technically, this is 125 in here. Pilot 2, pilot 1. This is 3.45. I know that this is 23, which in turn can give me this angle here because I've got 2. So I use supplementary angles to figure out the 125. That's worth a mark. If you get the 125 in there, you get a mark for that. And then we can figure out this one here. We use sum of triangle to come up with this one, which is 32. I'll give you another mark for that one. Okay, so 1 mark for that, 1 mark for this. Now I have a sine law situation. So I'm going to go sine of 32 degrees over 3.45 is equal to, which one was going to give me this? Because they want the distance between the current position and the airport. So we want this here. I'm going to call that x. I have to use sine of 23, this one, to give me that sine. Okay. If you do the work and then crunch the numbers, you get 2.54 kilometers. We're going to give you, I'm going to give you 2 marks for this, the setup and the work that is required there. So careful here. 2 marks for the diagram. 1 mark and 1 mark for each angle, plus another 2. So that makes this question worth 6. Yes, you heard right. You heard it. It's worth 6 marks. So don't be too generous if you didn't. This was learning and still learning opportunity here. So you decide what you want to give yourselves there. If you butchered your diagram, but you have significant amount of work, including finding one extra angle, I'd go 3 out of 6. Right? If your diagram has to be basically like what I have to get the marks, to get all 6. And then the bonus, if you got this as your area, okay, you're going to get a bonus, a +1. But we're not going to count it towards our total, right? Whatever is attributed to this. So we are at 3 and 2, that's 5, plus 6, that's 11. So this backside is worth 11 marks. 11 and 6, right? So 17 total. Put it right at the front here. Out of 17, your name and your last name, so I know who you are. And we're going to continue with trigonometry.